Hi, everyone, and welcome. This is the Oracle Autonomous Database Learning Lounge. I am Marco Serasivia, part of the product management team for Autonomous Database. And today we're going to have an amazing session. We're going to be having Debashish Singha. He's a vice president on the sustaining engineering team. And he's going to be taking you guys into the deep look at all of the under the hood of the Autonomous Database, right? So how does the service work? So he's going to be talking about real-time monitoring, early detection of any anomalies, AI-powered, right, detection of anomalies, identifying root causes, things like that, and also all the automated adjustments, right, that the Autonomous Database has. So throughout the session, we're going to have product managers looking at any questions you might have. Make sure you type them in the Q&A in Zoom, please, okay? And we're going to distribute some links to you guys in chat, okay? One of the links, the important links, is this one that you're looking at, which actually is the place where you come back to watch the recording, right, and check and register for new sessions and things like that. So speaking of links, I'm sharing right now some links in chat. So these are links that take you to getting started with Autonomous Database or how to reach to us in both actual LinkedIn, Blue Sky, and X as well. And then if you have any questions, right, you can ask the questions on Stack Overflow or the Developer Slack. So for Developer Slack, Oracle has an Oracle Developers Slack workspace that is free. You can join there and then search for the Oracle-Autonomous-Database, and you can ask your question there as well. Okay? All right. So without further ado, I would like to thank Debashish for joining us today. Thank you very much, Debashish. And you can start sharing your screen and take it away. And thank you again.
Thanks, Marcos, for the introduction. I'm Debashish Sinha. I'm part of the Sustaining Engineering org. I've been working on Autonomous Database since the beginning of ADB going live. Today, I'm going to give a perspective of what's going on the back end. So all these days, maybe you guys have been looking at all the features which are there in Autonomous. Today, my goal is to really take a deep dive. I'll start with a few slides in the beginning, but essentially in a couple of slides, we will start getting into the deep details of how we really monitor and run the service. So this is a regular slide you must have seen from our product management team, where essentially when you adopt Autonomous Database, you are reducing your cost, you're reducing your risk, you simplify your work, and then you accelerate fast, right? With all the tools that we have, the ecosystem provides, you're able to move pretty fast. With today, what I'm going to do is kind of deep dive into this part of it, right? That how does it lead to you reducing cost, and what do we do to enable you for this? Now, essentially, what we really offer here is, cost-effective licensing, which is part of the, licensing policies that we have. Of course, we provide end-to-end automation, which lowers your IT cost. And of course, like we provide patches on a regular basis. We have global certification in place, which reduces the risk. Now, on top of all of this is the automation which comes of it, right? So if you look at it, how do we really reduce cost? What we provide is all these auto features which are there, which is essentially what Autonomous Database is. We have auto provisioning, auto configuration, automatic backups, then auto scaling. There are a ton of auto stuff here, but essentially today, what I really want to focus is this part where we are automatically detecting issues, resolving issues for our customers. And these are all based on certain patterns that we see on the back end, proactively monitoring anomalies, proactively detecting and ensuring that they are tracking issues like Jira's or ticketing system that we have in our back end. And with you will see that I keep on repeating the word bug, but basically we have a bug database system in the back end which kind of tracks all the anomalies which are there in the system, and we go about finding resolutions for that. So that's the really deep dive that we'll do today. Now, this is based on our metrics that we have collected over the last multiple years that ADB has been live, right? 87%, or to be really precise, 87.7% of the issues which are overall reported are all internally detected. Essentially, customers really come to us reporting only 13% of the issue, or a little bit less than 13% of the issues. So essentially, we really strive for ensuring that we detect the issue, we resolve the issue, and we really don't want customer to be reporting issues to us. Some cases are not possible, but we are constantly evolving ourselves to make it better so that we can detect issues on our side. The other big advantage of ADBS is we are able to resolve issues like 4 times faster as compared to on-prem database. And the reason is pretty much clear. It's there on the right-hand side of the picture out here. Essentially, a lot of the time which is spent in getting diagnostics from customers are completely removed when you're running in ADBS, because the environment is with us, the traces are the diagnostic traces are available to us. We move really fast, right? Nobody needs to file a bug, nobody needs to file an SR before it comes to autonomous. We automatically file it. That's why this blue region is completely not there when you're in autonomous. We move patches very fast to production. As you're aware, every week we push fixes to production. So essentially, you get your fixes almost like 4x times faster. And of course, every time we patch, we are really moving stuff to production, or including security fixes which are there. Going ahead, and how are we able to do this? We are able to do this because our cloud operations team have almost like 8,000 metrics which they are monitoring, and out of this 8,000, there are like 1,500 which are really alarms. Alarms typically result in a pager call to the on-call ops engineer so that he can start triaging immediately and potentially come up with mitigation before the impact of the customer is significantly high. And from our side, and we'll go into deep dive into that, how do we do that automatic detection on our side, right? But essentially, the idea is to automatically detect that issue, automatically report the issue, page the on-call engineer, and then we are on it. And it's just not the operations engineer, but essentially a gamut of people who work on it. And I'll come to those details. Now, I'm just putting this slide out to show the scale at which autonomous database operates, right? We have like 37,000 new databases which get created every day. So our typical somebody sitting down and monitoring stuff is not going to be working. We need automated system. We need things which kind of self-mitigate to a significant extent. That's what we are really looking for. And then if you see the volume of queries, this is just giving you a sense of how much amount of work gets done in the backend. And to keep this thing running and humming, it requires, you cannot solve the problem with just by humans. So we have a lot of automation in the backend. We are trying to leverage AI ML to this significant extent. I'll show some examples or talk to a few of the things that's in the work or almost in the stage of going production. But we are really pushing the boundary here, and of course the backend also needs to scale up. It's just not the features which are out there, but essentially what happens in the backend also need to scale up. All these metrics are available in this URL which I shared here. Now, how do we achieve all of this, right? So this is really the working model, and I'm going to go over each part of it into detail. The idea is that on the left-hand side is where it starts, right? They are, that's how the tickets come in, then how the various ways the tickets gets filed, then how do we triage them, how do we mitigate them, how do we resolve them, and of course, as we go through this process, there's a lot of learning which comes out of it, and essentially showing opportunities for us to improve, to get better, to get faster, right? And that's where we have this CAPA thing. So I'm going to go over each item here and deep dive into each of it, and you guys will see what's really happening at the back end. The most important thing, the first thing is on-call, right? So on-call is not only support, it's just not support or operations which are on-call. Of course, they are 24/7, but we also have the dev team on our side. I have team members on my side, and I myself are on call for issues which needs to be attended by development. So everybody is on call in autonomous database, starting from support, operations, development, everybody included are on call. Now, the other part, as I mentioned earlier, right, 87.7% of issues are auto-detected. That's the goal for autonomous database. We want to detect it ourselves before even the customer gets to know. I know there are opportunities here. lot of you are customers here in this call. You might sometimes feel that, hey, why do I need to report an issue? Yes, maybe that falls into 13%, but most of the time it's like 87%, and we are really pushing that hard so that most of the issues are detected by us. So there are automatic tickets which come in. That's called T2 auto tickets which come in. There are alerts which come from AIC, AIM. I'll come to some of these acronyms. I'll expand later in the call. And then the other thing is whenever operations or support is reporting a defect to development, we have this app which makes things faster for the operations engineer to file a bug. And now we are the bug agent, which is on the bottom part, is essentially an AI agent which has been almost developed. We are going ready. It's already in limited availability. This is going to help significantly help the operations engineer, the support engineer, to kind of navigate before he even reports a defect. What we really try to do is deflect the request. When I say deflect, is essentially giving him alternate paths to resolve the issue, or even point him to an existing which is there. So this is all based on Gen AI. Now, coming to the monitoring part, I'll first go to the monitoring part before we go to the alarming part, right? So we have monitors these are the Grafana dashboards that you see here. We are looking at availability. We are looking at customer connectivity. This is a very important part that we can detect on our side if there is some, like sometimes you guys be seeing TNS errors which comes in when you connect, right? So those are monitored in our backend, and this is of highest priority for us. There are actually, these are all P1 alarms for the ops engineer. If there are connectivity issues, then he really needs to jump in to see, hey, is there an issue on our side, or is there just a configuration issue on the customer side? And all of them have a bearing here. Essentially, we look at what capacity, like one of the important things that we need to look at is some of the capacities that you have, right? Let's say once we reach, let's say an Exadata box has reached a certain capacity, we want to ensure that there are additional resources which are procured, and all those things are in place. Let's say we are running out of memory or we are running out of CPUs, then these are automatically provisioned, and for that we have alarms for that. There are tons of this, as I mentioned in the earlier slide. We're like 8,000 of metrics which the operations team are monitoring, and of course, and out of that, like 1,500 are alarms. We take our LCM flows very seriously, and the reason we being autonomous is really not to let the customer deal with all the nuances of managing things in the backend, backup happening in time, right? Let's say if you have configured, say, auto restart, or saying that, oh, my business ends at 5 o'clock, I want the database to be shut down and open by 7 o'clock in the morning. These are, life cycle management operations, and they cannot fail. And if there is a failure, we want to ensure that at least the customer gets mitigated as we do the root cause analysis. So there are alarms around all the LCM operations which are there. Availability is, of course, a very important one. And the other thing, the canary thing that we have developed, this is an evolving thing. What we have realized is sometimes we don't get the signals, the customer gets the signal. So canary is essentially a system on our side which kind of replicates the customer's environment. Are they connecting to service gateway? Are they directly connecting to SIEM? So there are a lot of this use case get into our canaries so that we can simulate customer use cases, that customer failures that we have reported and we are not able to detect earlier. And over time, we are evolving things and making things better, right? Then there are other tools which are there. We have CMAN, we have Apex. They're all alarms around that so that we can detect failures before even it starts impacting the customer. Going ahead. So now I come to the other part. So whatever I talked about is all typically operations teams looking at it. And now we are coming to the other phase where, even here in autonomous database, we want to ensure that where ops involvement is not required and development involvement is required, we are short-circuiting everything, and ops don't need to deal with it. If it is a development work or if it is something related to the code, it's better for the developer to run with this. So AIM is nothing but autonomous incident monitoring. So as you guys are aware, Oracle database, sometimes do have issues, like, for example, sometimes you hit an error 600, or sometimes you could be hitting even a generic error like 4036, running out of PGA memory or running out of SGA memory. So those kind of issues which results in a database incident, what we do is we have completely automated the flow. So if you see on the left-hand side, these are the Exadata boxes which are there. So what we do is periodically we pull diagnostics from the backend that whatever incidents have happened in this Exadata boxes are pulled into a jump host, which is an intermediary stage. We zip up all the incidents which are there and put it into object store. We put it into the corporate network. That's where the AIM system comes in. AIM is nothing but a system which will basically parse through the traces which are come in. It'll correlate with existing defects which are there in the database and say, hey, this particular incident is same as this particular issue, and this is the bug fix that we need to potentially deploy to production. Or if there's a new incident, we automatically file a bug, and the system has this runs every 60 minutes to triage all this information and either file a new bug or attach to an existing bug, and directly engages to the development team. Now, depending on the seriousness of the issue, the priority of the defects which get reported to us also changes. Let's say if there is a crash which has led to a background failure, those are of higher priority versus a foreground failure. So there are priorities attached to it, and they're constantly being monitored so that the customer issues get fixed before the even customer reports it to us. So this is on the database side, right? So essentially, a database failure which can happen. We have also automated at the second level. This is the Exadata level. Let's say, as you all know, autonomous database runs on top of Exadatas coming from XSCS environment. So we also look at the Exadata side. So if there are some cell site failure, if there are some cell site crashes, we also automatically collect those information and have the same flow, and then engage the right dev owners to start working on that. And if you see in this process, there is no manual involvement here. Neither operations, neither support get involved in any of this flow. The defect comes in, and the developer starts working on the issue. So this is some of the automation that we have in place, so that most of these issues directly come to development without anybody getting, neither customer, neither support, nor operations. So once this defects come in, or once the issue is kind of, typically if it is a high priority issue, we would have worked with the ops engineer or the support engineer would have worked with the dev on call to get the issue mitigated. And many times operations themselves have, standard operating procedure to get issues resolved by themselves. Now let's come to the middle part where the issue has been reported and we are trying to triage, right? So all this AIM incidents which I talked about are available in something what we call as autonomous incident console. This is one place where all the incidents are stored. How many defects have been reported, right? Which region is, so you have an Uber picture here. This is trying to show the entire gamut of systems that we have, but it's one place where all the ADB incidents are stored, all the AIM for XI incidents are stored. Even the JIRAs which have been filed are available here. So this is for self-service. The support engineer can come here and say, hey, I have this customer who had this issue, or my customer is reporting an issue, or the ops engineer is saying, hey, I'm seeing this failure. Is there some known issue here? They can come here, search for their incident, and get that information. And there are a lot of insights which can be created. Let's say if there's a failure on the database side because of a cell side issue, that correlation can be done here. And there are a lot of ways to slice and dice. There are sometimes which are where you see that, hey, I see this particular incident whenever patching is going on. So that kind of patterns can be seen out here. The other thing that we have, which is in development, and we have just finished all the security approval and should be going live in a couple of weeks, is this AIC chatbot. This is powered by a new plugin that we have developed called Converse AI. This will allow basically the support engineers to just chat on the data. And then, well, they don't need to search for anything, just using natural language. They can chat with the application, get the information that they want. They can say, hey, I am hitting this particular defect. Which is it coming in the next patch, or is it already deployed? I'm looking for whether this particular patch has been deployed in a particular region. All those information would be available just using natural language. That essentially speeds up a lot of stuff that a developer or the support engineer or the ops engineer needs to do. Now, this is another thing that I want to share, right? So I'm sure a lot of you guys are aware of this zero regression SLO that ADB has, right? So the essentially zero regression is if you're running on early access and you have reported an issue, we guarantee you that that regression or that issue that you're facing in your early access doesn't go to production. Now the time period is very small. Within a week of what you have, even if you report the issue on a Friday, we are supposed to adhere to this SLO. So we have very, very little time for us to diagnose an issue when a customer reports an issue in early access. So this automatic regression detection, there is the QR code which I have shared here. It's already a published feature that we have. So what we really do is all the SQLs which have been running in the backend, right? If they were working fine before, if your SQLs are working fine before and it stopped working for some reason, we automatically detect that and alarm ourselves saying that, hey, there is a potential SQL which used to work before has started failing, and we start working on it. Now, whatever I'm showing here is essentially a comparison between, how we used to do work before and how it is done today with this with AIC that we have. So basically what this application allows you is to compare or allows the developers to compare between two patches, what has changed between them. We also have an AI workflow here saying that, hey, this is the error the customer is getting. Do you think any of the transactions which have gone in the last patch are related to it? So we have a workflow for that, which is all AI based. And you can say that, hey, out of the X number of transactions which have gone in, hey, this one looks likely to be related to the problem that you are saying. So it saves a significant amount of time for the developer to narrow in and zoom into that particular transaction and potentially come up with a mitigation step, even coming up with a fix, or even saying that, hey, this one requires a little bit of more time of investigation. Let's yank that transaction out so that we can unblock the customer, right? So this feature helps us significantly to move fast, and it is really, really what is required for us to ensure that we are adhering to our zero regression SLO. Now, once all this is done, the defect comes in and we are all looking at it. Sometimes what happens is a developer would say, hey, I need a little bit more information from the backend, right? Now, if you see the number of databases that we have in ADB is in like almost 100,000 plus, right? So trying to address by humanly saying, okay, you need this trace from this database or this diagnostic from this database is humanly impossible. So what we have done is we have completely automated this end to end. So when a bug comes, a dev engineer can potentially go to a UI and then say that, hey, I am looking for this diagnostics. It'll make a request, and it's an asynchronous request. So it goes to the backend, it gets picked up in the backend, and we have automation in the backend based on the request which has been made. We can actually the automation collects that information and put it to object store and goes to the bug, and the developer gets intimated, right? So this kind of eliminates any dependency on operations to get the information, and this is how we are ensuring that the developer who is working on it is not blocked. The ops engineer doesn't have to spend cycle, collecting diagnostics. So this is completely automated with nobody from support or operations involved. And I'm sure a lot of your customers sometimes feel that, oh, I do get asked few things. Yeah, you do get asked few things sometimes when it is very specific to your database. And as you know, for security concerns, we don't go inside your database. If there is something that we need to know from you directly, that's where the request comes in. But if there is something which we can get from the backend, and it's like at the Uber root level, then we really don't need to go to the customer. And typically there are like 30 plus type of requests which are available, typically gets fulfilled in few minutes, but typical max time is like 60 minutes. The other thing that we have developed recently is basically based on the issue type which has come in, right? We have based on GenAI parsing the information, we can say, hey, this kind of issues typically require this kind of diagnostics. So it automatically makes a request. This is even without the human getting involved, saying that, oh, I think this kind of issues, this is an automatic storage management issue, and maybe we'll need all the traces from all the nodes of the Exadata boxes. So that goes to the backend, gets that information. The other beauty here is, as the diagnostics come in, even before the developer gets involved, we have something called as auto triage, which runs on it. Now, let me go into what is auto triage. So over time, right, we have been running database for years and years now. What we have realized is when the information comes in, there are few repeated tasks a developer would always do. You like to look at the alert.log. You'd like to look at the particular failure and try to do some parsing. Hey, why did this fail? What is the stack of failure, right? What does it say? That do I have a corruption somewhere, or do I have a failure because there's a OS level issue, right? So we have developed different parsers out here, which can basically automatically parse the information and give you the output. Like here, I have given an example where, let's say there's a crash in the process. Earlier, what you used to take is basically you get the core file, you attach your debugger to the core file, and then find out in which line you have failed. It takes quite a lot of time where you create the setup, you get the core file, you attach to it, and then you file. We have completely automated this. Like as soon as the trace comes in, the developer can say, hey, this is the line of code where the failure happened, and it will also tell that here's a register which has an issue and doesn't, like this register doesn't look initialized. Maybe we'll have to look at the code. Why are we not initial? Things like that, right? So we really make things faster. So before even the developer comes to the defect to start and looking at it, auto triage would have already run based on its own knowledge of what all things to be run. The other thing that we are developing that's in the last line is the triage AI thing. Triage AI is a system that we have built where we create expert documents. And when I say create, means it could be an existing document which is there. And based on the expert document, we send the expert document to an LLM, and then once that expert document is consumed by the LLM, we also pass in the potentially important diagnostics to LLM and can potentially use the expert document and give recommendations saying that, hey, this is what I'm seeing in the trace file, this is potentially what is wrong, and this is what potentially needs to be done to address the issue, or say we need some more information for it. A good example, it's like if you're getting Aura 1555, which is saying that you're running out of rollback segment, it can actually guide you what all needs to be done. That is there a problem? Is there a configuration problem? Or is there a defect on the RDBMS side itself that we are raising a particular error? So these are still in the pipeline. We are hoping that by this month it'll go live. But essentially, this will really ensure that all the expertise that we have built over time can be extended further by using LLM, so that we can start, triaging in parallel to human before even the human comes in. Now, taking a slightly different view of what else is available. So we have this backend system we call it the admin UI. This is one place for administration where operation uses for administration. And the access control is completely what operations needs to see, what a support engineer needs to see, what development needs to see are all regulated. But this is one place that operations use for looking at all the backend systems, right? Like a typical example is, let's say there's a customer issue which comes in, and I need to know as a developer, I need to know, hey, how many CPUs does this PDB has? How many CPUs does this database have? What is the storage configuration? Has the customer enabled auto scaling? Has the customer enabled auto scaling on the storage side, right? Or let's say I want to see all the operations the customer has done, all the LCM operations which has happened. So everything is there in this admin console. So this is one step. This is one place where the ops engineer or the support engineer can come and look at all the ecosystem, all the jobs which have been running, where are they running, which region it is, all this information is there. The other awesome thing that we have is this OpenSearch system that we have. Now, as you guys know, this is super important for running or diagnosing, right? You are constantly streaming all these logs. We have alert logs, we have CMAN logs, all the logs which are typically are required for diagnosis are all pumped in here. And the beauty of this, I'm sure a lot of you guys have used ELK kind of a system, and this helps us to really find out what's going on in the backend, and it gives the developer the complete view of what's happening in the backend. And these are like, based on the issue, there are a lot of issues where before even the ops engineer tells us that this is going wrong, or this is what we are noticing, we have seen where we just look at this, the dashboard, the OpenSearch dashboard, and we can say that, hey, I see that in the alert log, this is where the warning message is coming. You should be doing blah, blah to mitigate the issue. So this gives the developer an insight of what's happening in the backend without even going to the backend, because that's, we don't really, the developers don't get access to the backend. Those are mostly operations for us. The streaming which goes out of the system into admin UI is where we view all of this. This is of significant help. One of the most important things that we have found out of this is, let's say there is patching going on in the backend and there is an issue going on. So we have actually inbuilt dashboards now, which will say that, hey, when the customer had this issue, or when we had this issue in the going on in the backend, patching was going on. So that kind of correlation becomes very, very easy with this kind of system in place. The other big thing, this is a thing which has come out lately. This is what we call a SQLStats. So we look at every SQL which is there in the system. We track every SQL which is there. And then we look at the CPU time, the elapsed time, the disk read time. This helps operations and supports significantly whenever a customer comes back saying that, hey, my SQL has run and started running slowly, right? So this gives a complete picture. Oh yeah, yesterday it was running fast, today is running slow. But then we can give the information, hey, you know what, you seem to be processing more data today than yesterday. Maybe that's the reason the elapsed time is higher. So this one gives them an immediate, information around what might be causing the issue, or at least come up with mitigation saying, hey, it looks like the plan hash value has changed for your SQL, and maybe that's what's causing an issue, and they can start deep diving to it, right? So this one is available, and by the way, I'm sure you guys are subscribing to the events that we send out, and one of the events is essentially saying is about how your SQLs are performing. If your SQL has degraded over the last 7 days, right, then we send you a notification saying that, hey, this SQL seems to have been performing well, has started to degrade, and you need to take a look at it, right? All those alarms or all those events are also based out of this system. So this is available both for you in an event form and for us on the backend to look at the entire history. So moving ahead. Now, once all of this is done, right, let's say we have found the root cause, typically we will come up with an patch, because given the size of the fleet, operations cannot deal with the standard operating. Oh, when this happens, go do blah blah, right? Sometimes it is, sometimes we do request, but that's really not scalable. So we have this technology called as online patching, where you can actually patch the Oracle binary on the runtime. And we have used this like for empty number of times in AWS to mitigate issues. So we typically end up coming up with a, you can say it's like a hot fix that we want to give to the customer or to the entire fleet, so that we can mitigate certain issues we have there. So, and then the other option is, of course, SOP. And the other thing which I want to call out is, as we build this SOP, actually operations recently have built a AI chatbot, which basically consumes this SOP, and the ops engineer doesn't need to really go. Let's say he's seeing an issue in the chatbot that he has, he can actually saying that, hey, I'm getting this error, what am I supposed to do with it? Then the chatbot basically goes to the backend, looks at the latest SOPs which are there, and say, hey, looks like your issue seems to be related to this new issue which is showing up in the fleet, and this is what you're supposed to do to mitigate the issues. So we are trying to develop and leverage AI so that we can move faster in helping customers. Now, what I'm here showing is a typical example of how things flow. This is also in the Oracle documentation, if you guys have seen it in the maintenance page. Essentially, this is really talking about how we are continuously, looking at customer issues along with all the features that we ship out, and we are continuously making solutions for them, fixes for them. That we build it, we basically test them in our lower environments, in our pre-prod environments, and then we deploy it through object store. And here, if you see on the third pillar, you can see dev, stable, pre-prod. These are essentially our QA environments before we really ship to production. One thing we have not called out here is essentially early access. What happens is patches, once they are deployed in dev, stable, and pre-prod and signed off, we'll typically deploy it in early access 1 week before it goes to production. And I do have a slide about it. I'll talk about it, but that's how we operate, right? On a continuous basis, this is done every week. And there have been very, very few occasions in the last 6 years or 7 years of ADB that we have missed this cadence. Now, in spite of doing all of this, there are learnings which come out of it, right? And we follow the CAPA process to ensure that we are learning continuously. So typically, if there are some major incidents, like in the OCI terminology, we can call it as a knock incident. We look at the impact, the blast radius, how much time did we take to mitigate, how much time did you take to detect it, how much time did you take to, completely resolve it in the fleet, right? So there's a blameless postmortem which is done. We review those incidents in detail, and sometimes the stakeholders are also involved when we do this review. We review the gaps and opportunities. We use the 5 whys principle to look at it, and we look at all aspects of it, right? What changes had to be done on the product side, what monitoring improvements we had to do, right? What process improvements we had to do to achieve the goal, right? To address the gaps that we have seen as part of the major incident or the knock. And of course, all of these items are ticketed, and there are follow-ups, and our release management team kind of helps with ensuring that all the tickets are kind of addressed and on a timely manner. And of course, the most important is ensuring that the hot fix or break fix is given to the customer so that the customer is unblocked. But for the rest of the improvements are all tracked through Jira's, either code being merged or processes being defined. And this is judiciously followed for any major incident which is there. So just to recap, this is the entire process that we have in the backend. Hopefully, I've given you some insight on how we operate on the backend. But if there are more questions, we can take it later in the presentation. Now, given that all of you guys are here, I want to take this opportunity to speak a little bit about, this Aviator program that we have. This Aviator program is completely run by the dev org, mostly run by my team. What we are really trying to do is we are trying to help customers to help us. We are trying to see that you adopt to the early access patch level so that your environments which are running your QA environment or your dev environment are actually moved to the early access. The Aviator program essentially gives you an overview of the patching. We handhold you with helping out what's the best practices around using early access. You can join this, you can sign up. I've shared the QR code. You guys can drop us a mail, and then we'll help you out. And in the next 2 slides, I'm going to explain what is it, right? So early access gives you, essentially, you get access to certain patches before it goes to production, right? They're like typically database patches, which you get to access it 1 week before. And if you're running your test systems, or if you're running your canaries, it's the best place to see where, if there is something which is potentially going to production and might break your application. And this is where the zero regression SLO service level agreement comes in. If you guys have reported the issue, and we ensure 100% that that issue doesn't go to production, and we fix it working with you, right? And when you are part of this Aviator program, there are a lot of benefits which come of it. There are best practices guidelines. We help you with the onboarding. Most of our issues, 60% of our issues are reported through this Aviator program, and which we are very proud of it. And of course, your tickets or your Jiras or SRs are accelerated. And this is nothing to do with you need to do, but essentially we have a mechanism in place that when ops or support gets a ticket and it's associated in early access database, it's like P0, because the window in which we need to operate is very, very small. So we need to really, really move fast. And here the request is, if you have dev instance, QA instance, which are running on regular patches, our request is you move it to early access. There's no cost associated. There are now, in the console itself, you can do it automatically. You can say, hey, move my database from regular to early. These are all available. You can do it. And there's no cost associated here. Even the Aviator program, there's no cost associated. We just help you out with the best practices. And there are a lot of other features. You can use application replay. You replay your production load in your QA environment. There's something newer things which are coming in, which is also going to make it easier for you to replay stuff on your test side. So we'll help you with all the best practices. Please connect with us. We'll help you out. This picture is just showing a workflow of how things are done. Like, we onboard you, we monitor your system. If there's an issue with your early patch, then we basically fix the issue, we redeploy the patch, and then only it goes to production. This is a high-level pictorial view of what we really try to do. So please join the Aviator program. I've shared the QR code. Please join us, and then we can connect. Going back to my original site, right? We are all here in Autonomous Database to reduce cost and risk. It helps you to simplify your work. And of course, we really want you to accelerate, focus on your stuff. The database part, leave it to us. You can focus on your application and your end business goals. That's about it. Thank you, Marcus.
Excellent. So thank you again, Devashish. That was great. A lot of great information. We had questions already answered there, but everyone, if you guys have questions, please type them in the Q&A in Zoom, okay? And we have PMs looking at them, and then Devashish also would be able to answer them, okay? So for now, I'll again share with you guys in chat all of the links that I shared in the beginning on the autonomous database, okay? So these are how to get started with it, right? The information about it, how to ask your question, right? Using the external workspace in Slack. And yeah, that's it. So guys, final thoughts again, to come back and watch the recording of this session and all the other sessions we have and look at the links. They're going to be on this address you see here. Okay. So I'll make sure to have also the links that Devashish shared inside the description of that video. And if you're watching this as a recording as well, you'll see the links in the description of the video on YouTube directly as well. Okay. I see a couple of questions there popping up now. So maybe we can answer them right now. So in case of requirement for moving the ADB to a different Exadata infra.
So in case an ADB needs to be moved to a different Exadata infra, example, in case it must be scaled up, there is no capacity in the infra, how is it handled? Yeah, so Jacob, let me try to answer, right? Typically, we try to ensure that there is enough capacity, but in case you want to scale up and it goes beyond the infra's capability, we don't want to automatically push you out of that Exadata to another Exadata because that will lead to an outage. So that needs to be worked off, and that's why I really wanted Yasin to answer it. But we would not do that because typically you will end up losing your existing connection. So it will lead to an outage. So we would like to work with you to get that addressed if such a situation arises.
Okay, so there's someone asking about the auto detection feature that you explain, whether it's for Exadata infra only, it's cloud.
Yes. Yeah, it's mostly for cloud. It's mostly for autonomous at this point of time.
Okay.
So I think somebody's looking for the Aviator program. Maybe we'll share the QR code again from the channel. Yeah, this one. Yeah, if you guys can scan this QR code, it will take you to this page, and you will be able to sign up there.
And then someone asking about the self-healing portion.
Yeah, self-healing is, at a higher level, as I mentioned, all the automatic tickets which get filed to us, we get them resolved quickly. If the urgency is significantly high, then we fix it immediately and ship an online patch without requiring any downtime from the customer. That's the self-healing part that you don't need to report to us. We will take care of it from the backend.
Okay, excellent. Great. So thank you again, Devashish. Okay, someone asking if we have access to review Grafana monitoring tools for advanced performance issues.
Yes. Yeah, they are the logs. These are mostly available in the backend, but if you are a customer, then your perf hub should be doing all the job. But if you have additional requirements, then of course you can reach out to our PM team to see, okay, what else do you need for your monitoring?
I just wanted to add, there is also the metrics that we sent to the OCI monitoring service. You can consume those and you can push those to Grafana yourself as well. That's another option.
Okay. Great questions, guys. So thank you again to everyone. I think we are done. I'll leave this open, guys. If you have questions, you can still type them in the Q&A. Okay. So I'll leave this for a couple more minutes. Again, thank you for joining. Thank you, Devashish and Yasin, for answering the questions. And I will just play some exit video, but I'll still be monitoring the Q&A, guys, if you have any more questions. Okay. And thank you again.